Hello, class. Today we're going to cover Math 131, Objective 11. In this objective, we're going to factor the difference of two perfect squares and a perfect square trinomial, okay? So first, we're going to look at factoring the difference of two perfect squares, okay? So if we have a squared minus b squared, we can factor that to be a plus b and a minus b. And here are two examples of how that would kind of look. If we had x squared minus 25, we would kind of rewrite it into that a squared minus b squared format, which would be x squared minus 5 squared. And with that, we will be able to get x plus 5 and x minus 5. The same if we look at y squared minus 81. We can put it in that a squared minus b squared format to get y squared minus 9 squared. And once we have that, the y and the 9, we can write the y plus 9 and the y minus 9, okay? So we want to, write it in that format, find those two things that are being squared, and then that's what we will use to have our two binomials. We also want to make note that the sum of two squares, a squared plus b squared, does not factor over the integers, okay? So an example of that is if we had x squared plus 25, if we tried to break that up and have x squared plus 5 squared, it would not be factorable over the integers, okay? So let's look at our first example. We're going to factor 4x squared minus 81y squared. So we want to pay attention to the fact that we have a subtraction sign in the middle, okay? Remember, we are doing the difference of two perfect squares, not the sum. The sum is not factorable over the integers, okay? So we want to keep that in mind. Then when that checks out, we want to look at both of the terms and see what is being squared. So if we look at 4x squared, what is being squared is 2x, okay? If we look at 81y squared, what's being squared is 9y, okay? And after we have the 2x and the 9y, now we can write this as 2x plus 9y and 2x minus 9y, okay? So that is how this works. Of course, if you are in doubt about if you did it correctly, you can most definitely multiply that through by doing the FOIL method and multiply it back through, and you should get what we started with, okay? So let's keep on going. All right, more examples. So for example 2, we have 25x squared minus 1, okay? And our little shortcut that we can do, we can write our two groups and figure out what is being squared. So for 25x squared, that will be a 5x that's being squared. And for 1, that's just going to be 1 being squared, okay? So now that we have the 5x and the 1, we can write our binomial. So we got 5x plus 1 and 5x minus 1, okay? For example 3, we have x squared minus 36y to the 4th. again. Let's think about what's being squared. Of course, x squared is just going to be x squared. For 36y to the 4th, 6 squared will give us 36. And what will give us y to the 4th? Y squared, okay? So now that we have the x and the 6y, we got x plus 6y squared and x minus 6y squared, okay? If we look at example 4, we have x plus y squared. So that means that we already see that all of that is being squared. Then for the 4, we know that that is going to be 2 squared, okay? Now we have to write both of them out. So we got x plus y plus 2 and x plus y minus 2, okay? Example 5, all right? We got x squared plus 16, all right? Something you should notice from the jump is this plus sign, okay? If you go on to do x squared plus 4 squared and all of that, it's still going to be non-factorable over the integers, okay? Remember that plus sign, it is not factorable over the integers, okay? All right, example 6. We have 36a squared minus 49b squared. So let's write our little shortcut, figure out what's being squared. For the 36a squared, that'll be 6a. And for the 49b squared, that'll be 7b, okay? Then we can write our sum and difference, okay? We got 6a plus 7b, 6a minus 7b, okay? And for our last example for this part, we got 25x squared minus 81. So 25x squared, we can break that up to be 5x. 81, we can break that up to be 9. And we will have 5x plus 9 and 5x minus 9, okay? So that is how we do part 1, all right? When we are trying to factor the difference of 2 perfect squares. Let's move on to part 2. For part 2, we're going to look at factoring a perfect square trinomial, okay? In order to do this, the previous knowledge we need to know is that a squared plus 2ab plus b squared equals a plus b squared. Also, a squared minus 2ab plus b squared equals a minus b squared, okay? So remember, we're going backwards, okay? In the previous objectives, we were multiplying. Now we're going backwards and we're factoring and breaking it down, okay? So if we look at these two examples, if we had x squared plus 10x plus 25, we could break that up to be x plus 5 squared. The same with y squared minus 12y plus 36. We can break that up to be y minus 6 squared, okay? And the way we would do this, I'll take this one right here. if we broke it up, if we used the formula that we have, we could break it up like this. And we will figure out that it is x plus 5 squared, okay? The same with this one. It will be y squared minus 2 times y times 6 plus 6 squared, and that will let us know it's y minus 6 squared, okay? So let's look at this first example so we can kind of talk about how this works. So we want to look at these two, all right? We have 4x squared plus 12x plus 9, okay? So if we look at the 4x squared, that is going to be 2x squared. And if we look at the 9, we know that's going to be 3 squared, okay? For that middle term, it would have to be 2 times 2x times 3. So if we did that, we would get 12x, okay? So that's one way to kind of figure out if we have the right answer. That middle section should equal the same, okay? But if we just go by the first and the last, and we think that we have it, I recommend that you multiply it through. Make sure you check it, and you should, after you multiply this, you should get that back. That's going to let you know that this is the correct binomial squared, okay? Let's look at some more examples. And the more of these that you do, the easier they get. You will just be able to just kind of look at it and tell what you need to do. All right. Example 2. We have x squared plus 13x plus 36, okay? So if we just look at the beginning and the end, all right, that would be a x and that would be a 6. So we could say maybe it's x plus 6 squared, okay? We could say that. But let's check it. So x plus 6 squared, let's say we want to do the FOIL method. And we multiply this through, we'll get x squared plus 6x plus 6x plus 36. And that middle term will be 12x, okay? Which is not what we want. We want the middle term to be 13x, okay? So that means that this right here is not it. All right. So that means that we're going to have to factor this a different way, okay, which is perfectly fine. We know how to do this. So since this is in the form that we previously talked about where we don't have that a in the front, we can try to factor this by doing the two groups, put the x there, find the two numbers that multiply to be 36, and they have to add to be 13, okay? So if we look at some factors of 36, we can get 4 and 9 that will multiply to be 36 and add to be 13. So that would be x plus 4 and x plus 9, okay? So in the future, you may just get an equation and be asked to factor, okay? You have to be able to think about all of the ways that we have factored to figure out the best way to do it, okay? In this case, doing it this way was the way we could do it. We couldn't do the perfect square trinomial method, okay? So keep that in mind. All right, so let's look at example 3. We have y squared minus 8y plus 16, okay? If we try to do this method, we will have a y and a 4. So the possibility could be y minus 4, and it's going to be minus because of that minus sign. So that would be y minus 4 squared, okay? And if we think about the shortcut and everything, and we try to figure out what it would be, we really want to figure out what that middle term is going to be. That middle term is going to let us know if it's right, okay? So when we multiply it through and everything, the middle term does check out. It will be negative 8y. So that means that the solution, or, after we factor it, we will indeed get y minus 4 squared, okay? Let's look at the next example. All right, example 4, we have 25x squared plus 30x plus 9, okay? If we try to break this up, using the formula, we would have 25x, we could break that up into be 5x. 9, of course, we could break that up to be 3. So that middle term, we would have to have 2 times 5x times 3, which is plus 30x, okay? So that means that the 5x and the 3 is what we need. 5x plus 3 squared, okay? Let's look at example 5. Since we have a minus sign here, let's set up our little shortcut. That first one, the 4x squared, we could break that up to be 2x, and the 25, we can break that up to be 5. All right. And for the middle term, it should be negative 2 times 2x times 5. What will that get us? Negative 20x, which is what we need, okay? So the 2x and the 5 will get us to our answer. It'll be 2x minus 5 squared. All right? So again, the more you look at these, you kind of get the hang of the shortcut that you are, plugging into and looking at to figure out if it is the answer or not. And we have just a few more examples, okay? These are our last 2. So for example 6, we want to look at the 9x squared and the 4. That will be 3x. Because of this plus sign, it'll be a plus. And then the 4, we could break that up to be 2, okay? So this is what we think it could be, but we need to check that middle term. The middle term is going to be 2 times the 3x times the 2. So that will be 2 times 3, which is 6, times 2, which is going to be 12x, which is what we need, okay? So that means that this is the answer, okay? And last but not least, for example 7, we have 4x squared minus 17x plus 25. If we do the shortcut, all right, let's see what we get. All right, so if we look at this first one and the last one, and we get the 2x and the 5, the middle term that we get is going to be negative 20x. We're not going to get negative 17x, okay? So that means we need to try to factor it a different way. So what we have is 4x squared minus 17x plus 25. We do have an a in front, so we need to multiply the 4 times the 25, which is going to give us 100. So we need two numbers that when we multiply them, we get 100. And when we add them, we get negative 17, okay? So let's list out our factors of 100. We got 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10, okay? So all of these, if multiplied, will give us 100. Which one of these, if added, will give us negative 17 at that? So let's see. To be negative 17, we could also have the variations of this to equal 100, where both of them are negative, right? So this is us, exhausting our possibilities, okay? Still don't see one that will add to be negative 17. We have wrote out every factor that we can multiply to get 100, and we do not have one that we can add those to get negative 17. So this one is non-factorable over the integers. Okay, again, don't just put non-factorable, all right? You need to make sure that you exhaust your possibilities, okay? We want to try everything before we just say we can't do it, all right? So that completes part 2. Part 2, again, was factoring a perfect square trinomial, okay? So in this objective, we had 2 parts. We talked about how to factor the difference of 2 perfect squares and how to factor a perfect square trinomial, okay? So that completes objective 11 of Math 131.